Dear students, this video is meant to explain you how to convert decimal numbers into binary numbers and binary numbers into decimal numbers. See, decimal numbers are the numbers that we generally use in mathematics, or the numbers that you have studied so far. Decimal numbers are having a base 10. They use 10 digits to form numbers from 0 to 9, whereas binary numbers, this is used by computer for its calculations. Means the CPU of the computer, it uses these two these numbers, means binary numbers, for their calculations. Binary means it is having only two digits. The two digits are 0 and 1. So the number that we are going to get after conversion will have only zeros and ones. But the number that we use, that has 2, 3, 4, 5, etc., but you cannot see these numbers in binary number system. Binary number system will only have zeros and ones. So we'll see how we convert numbers from numbers from decimal to binary. We'll learn this by taking examples. In last previous class I had explained that, but you see, I think most of them you may not have understood that properly, and some of the students even did not attend the class. So see, we will take one by one example and see that how this conversion is done. It is simple division, but you see, we need to collect the reminders in each step to form our binary number. See, we have to divide, means whenever you convert a decimal number into binary number, we need to divide the given number by 2 in every step until you get 0. See, 10 we are going to convert into binary number. 10 is a this 10, which I have written, it is a decimal number. We need to find out the binary number equivalent to 10. See how the calculation is done. First, you need to make this bracket, write 10 inside. This is our given question, and you need to divide this by 2, and adjacent to 10 you write remainder. We need to collect remainder in each step. Now we will start the division. See, we are going to divide 10 by 2. You know the division bracket, etc. When you divide 10 by 2, your answer will be 5. Quotient means I am talking about the quotient. We are going to write quotient here, and reminders we are going to write here. So quotient in this case will be that now 10 divided by 2 will be 5, and no reminder will be there because it is that you can divide completely 10 by 2. So reminder will be 0. So you collect that reminder here. So in this step, reminder is 0. Next, now you are going to divide 5 by 2 again. If you divide 5 by 2, your quotient will be 2. You can divide 5 by when you divide 5 by 2, you will get quotient 2 and remainder will be 1. 2 times will be there, 2 in 5, and 1 will be remainder. That 1 you need to write here. Means you in every step in the division you have to write remainder here below this remainder section. Next, you see, you need to divide 2 by 2 again, because we need to proceed this calculation until you get quotient 0. Means here you need to get 0. Till then you need to divide the means the number by 2. So we will divide again by 2. So when you divide 2 by 2, answer will be 1, and no remainder will be there. So we need to write 0 here. Means 2 ones are 2 plus 0 equal to 2. The answer will come. So next, you see, we haven't got 0 yet. 1 we have got here in quotient section. So you need to divide 1 by 2 again. So if you divide 1 by 2, you know that now you cannot divide that one. Answer will be 0. Quotient will be 0, but 1 will be remainder. Okay, if you divide 1 divided by 2, that means there is no 2 in 1. So quotient will be 0 and 1 will still remain as a remainder. Now this division is completed because we have got 0 in quotient section. Means this is the quotient section. In quotient section you have got 0. If you got 0 in quotient section, we will complete the answer by writing like this. See, this is our question. 10 with base 10 means decimal number 10 equal to equivalent concept. What is the equivalent to this number? See, this will be, means you have to write the reminders from reverse order. means from bottom to top. 1 0 1 0 means this will be the binary digit equivalent to 10. Means the 10 that we are talking about is the decimal number system, the number that we use generally, means the humans use, and this is the computer's 10. Computer's 10 will be like 1010, but our 10 is just 10. So this is the difference. So we have converted 10 successfully into binary digits. This is how computer do. When we enter 10, computer will convert that number into 1010, then we'll start doing the calculations. We'll take another one example. 28. We will convert 28 into binary digits. We will follow the very steps that we did in the last case. First we will write 28 inside, then we will divide this by 2 and we'll write here remainder. Now we'll start dividing. 28 divided by 2, you know the answer will be 14. You see there will be no remainder because you can divide completely 28 by 2. So here remainder is 0 that you have to write here. Next we will divide 14 by 2. If you divide 14 by 2, you will get a quotient of 7. Here the answer will be 7, quotient will be 7, and no remainder will be there because 2 sevens are 14. So remainder is again 0. Next we will divide 7 by 2 again. When we divide, we will get 3. 2 threes are 6, but this will not make 7. 1 is remainder here, so that 1 will be writing here. So you need to write 1 in the remainder section. Next you see this division is not over yet because we haven't got the 0. We need to continue the calculation until we get quotient 0. So we'll divide 3 again by 2. When we divide 3 by 2, we will get quotient 1. 2 ones are 2, then 1 is again remainder that you need to write here. Next you see we haven't got 0 yet, so we'll divide 1 by 2 again. If you do that one, even the last case we have seen, we will get 0 as quotient and 1 as remainder, because in 1 there is no 2, so 0 2 say and 1 will be the remainder. Now we have completed the division. Now we'll write the answer. See, as we wrote in the last case, we'll write 28 with base 10 is equal to, this will be the answer, 1 1 1 0 0, means from bottom to top. In reverse order you need to collect all these reminders and write it adjacent to one by one. So you will write 1 1 1 0 0 base 2. That means our 22 in mathematics, in decimal system 28, it is equivalent to 1 1 1 0 0 0 in binary system. So these two numbers are equal. Okay, we'll take one more example. See 57. We will follow the very steps that we used in the last two cases. 57 divided by 2, then remainder section. First we will divide 57 by 2. We will get an answer 28. Means I'm not explaining this to you because you are in 7th class, you know this division very well. Yeah, you have done this many a times while you are finding HCF, LCM, etc. So I don't want to explain this. You know that if you divide 57 by 2, you will get answer 28. But 1 will be remainder because 2 28s are 56 only. So 1 will be the remainder that you need to write here. Okay, next we will divide 28 by 2. We will get answer 14 and there will be no remainder. 2 ones are 2, 2 fours are 8. That means remainder will be 0. Now in the next step we need to divide 14 by 2 again. We will get answer 7 and no remainder. Then we will divide 7 by 2 again. We will get answer 3 and 2 threes are 6. It is not 7, so 1 is remainder. So we'll divide 3 by 2 again and we will get answer 1 and 1 remainder. 2 ones are 2 and 1 is remainder, and we haven't completed the division yet because we haven't got the 0. We will divide 1 by 2 again. If you divide 1 by 2, you will get answer 0 as quotient and 1 is remainder. That means the calculation is over. Now we will write the answer as 57 to the base 10 is equal to, this will be the answer, 1 1 1 0 0 1. Means your answer will be 1 1 1 0 0 1 to the base 2. Now this one is equivalent to 57 in decimal system. This is computer's 57. This is our 57. That's difference. Now I think I have explained you this by taking 3 examples. You can do this with that more questions, means more numbers. If you practice, then it will become easy for you. You need to practice, then only you will be able to do this one. You understand that in binary system only ones and zeros will be there. We have studied that so many a times that no computer language only contains ones and zeros. You see all these answers that we are writing now has got just ones and zeros. It will be so. Next you see, now we are going to study how to convert into decimals. Means just imagine you are given binary numbers and you need to convert this binary numbers into decimals. Means we are going to do that now, the reverse of this one, what we have done so far. Means you will be given binary and you will be converting this into decimals. Means you will be given the computer's numbers and you will be converting that into our numbers. So we will take that 3 numbers that we have calculated in the last 3 examples and we will try that now getting the answer in decimal system. See, the first answer we got was 1010 base 2. This was equivalent to 10. We will see whether when we convert this into decimal we will get the correct answer or not. And second answer we have got was 11100 to the base 2. This was equivalent to 28. Then C, 111101 base 2. This was equivalent to 57. And before we do this, let me tell you that something that you have learned, but I need to remind you. It is, see, just imagine if suppose you are given a number 1234 to the base 10, means 1234, the number that we are using in mathematics. It could be written like this. You see, like 1, this 1 stands for 1000, 2 stands for 200, 3 stands for 30, and 4 stands for 4. We know that now we say this as a place value: ones, tens, hundreds, thousands. So this could be even written in this manner. Maybe that you have studied this in mathematics, or else maybe that you are going to study this year in 7th class. I don't know exactly whether you studied it or not, but you understand that now this could be expressed like this as well. Like you see, first I have written 1 into 10 raised to 3. 10 raised to 3 stands for 10 into 10 into 10. You need to multiply 10 3 times, means 10 into 10 100 into 10 1000, means 1 into 1000. This will become 1000, right? Then 2, you can write 2 into 10 raised to 2. See, yeah, my 10 raised to, this was 10 raised to 3, this is 10 raised to 2. Then here it will be 10 raised to 1 and this will be 10 raised to 0. I repeat, see, this is in the thousands position, that's why we have written 10 raised to 3. This is in the hundreds position, that's why we have written 10 raised to 2. And this is in tens position, that's why we have written 10 raised to 1. And 4 is in ones position, so we have written 10 raised to 0. Now you see the values. 10 raised to 3 means 1000, 10 raised to 2 means 100, 10 raised to 1 means 10, 10 raised to 0 means 1. That's the meaning. 10 raised to 0 means 1. Means any number with power 0 is 1. So this is 1, this is 10, this is 100, this is 1000. This simply stands for the place value. Here is 1 into 1000, 2 into 100, 3 into 10, 4 into 1. What will be the answer? We will see. See, if we find the answer, 1 into 10 raised to 3 will become 1000, 2 into 10 raised to 2 means 2 into 100 will become 200, 3 into 10 will become 30, 4 into 1 will become 4. Understand that 10 raised to 0 is 1, 4 into 1 is 4. Now when we find out the answer, we will get again 1234. This is same, means this is just what, expanded form. Here we see we have written 10 raised to 3 because here base was 10. The very mathematical logic will be used to convert these numbers into decimals. See how we do that. This is our question, first question, 1010 to the base 2. Now how we are going to convert this, you see, 10102 equal to 1 into 2 raised to 3 plus 0 into 2 raised to 2 plus 1 into 2 raised to 1 plus 0 into 2 raised to 0. See how this has come. First we have written first digit 1. 1 we have written here. Then 2 raised to 3. Why? Because you see here base was 10. We wrote 10 raised to 3. Here base is 2. So we have to write 2 raised to 3. Then here we have to write 2 raised to 2. Here we have to write 2 raised to 1. Here 2 raised to 0. The simple logic is when the base is 10 you write with 10's powers. When the base is 2 you write with 2's powers. Okay, so here first 1 into 2 raised to 3, then next digit is 0, 0 into 2 raised to 2, the next digit is 1, 1 into 2 raised to 1, then 0 into 2 raised to 0. See 2 raised to 0, 10 raised to 0, 2 raised to 1, 10 raised to 1, 2 raised to 2, 10 raised to 2, 2 raised to 3, 10 raised to 3. Means the very same logic we have used. Here this was having base 10, these numbers are having base 2. Then in the next step we will find these answers. You see here before we write the answer, see 2 raised to 3 means 2 into 2 into 2. Just like here 10 raised to 3 I have told you 10 into 10 into 10, right? 10 into 10 100 into 10 1000. Here 2 raised to 3 will be 2 into 2 into 2 means 2 into 2 4, 4 into 2 8, 8 into 1 will be 8. Then 0 into 2 raised to 4. 2 raised to 4 means 4. 4 into 0 will become 0. Then 1 into 2 raised to 1. 2 raised to 1 stands for 2. 2 raised to 1 means 2 because 10 raised to 1 was 10. So 2 raised to 1 is 2. 2 into 1 will be 2. Then 0 into 2 raised to 0. 2 raised to 0 stands for 1. 1 into 0 is 0. So here when we plus these numbers you will get 8 plus 0 plus 2 plus 0 equal to 10. See I have told you this number we had converted earlier, and we know that the number that from there we started the conversion was 10. The decimal number was 10, and after converting this again into decimal numbers we have got the answer again 10. Means 1010 to the base is same as 10, right? So we have then successfully that now proved that we can convert into decimals and to binary digit, and from binary we have to convert, we can convert into decimals as well, and we'll get the same answers. Means 1010 is uh, same as equivalent to 10 in decimal system, that we have proved. Now we'll see whether we will get 28 for this number. We'll do the conversion as I shown you. See this was the question that we have got, and we will write here. See 1 first digit 1 into, here I will write 2 raised to 4 because you see it has got more digits. In the last question we had 4 digits. Here we have 1 2 3 4 5 digits. When you have 5 digits you need to start from what, 2 raised to 4, because you see 1 2 3 4 5, this will be 2 raised to 0, this will be 2 raised to 1, this will be 2 raised to 2, this will be 2 raised to 3, this will be 2 raised to 4. So 1 into 2 raised to 4 plus 1 into 2 raised to 3 plus 1 into 2 raised to 2 plus 0 into 2 raised to 1 plus 0 into 2 raised to 0. It will come like that. Means 2 raised to 4, 2 raised to 3, 2 raised to 2, 2 raised to 1, 2 raised to 0. The other numbers that you need to write along with this are that 1 1 1 0 0. You need to write numbers like that. Now we will find out the answers. You see simply what will be the answer of 2 raised to 4. We'll simply make a rough calculation and see 2 into 2 4 into 2 8 into 2 16. So means 2 raised to 4 means the answer will be 16. So 1 into 16 will be 16. Then 2 raised to 3 means 8. We have seen in the last case as well. 8 into 1 will be 8. Then 2 raised to 2 means 4. 4 into 1 will be 4. Then these two numbers you see 0 is there. If you whatever may be the answer, then if you multiply by 0, answer will become 0 0. So when we add this we will get 16 plus 8 24 plus 4 equal to 28. We got the same answer again. Means 28 we had earlier converted into decimal and we got this answer. Now this binary we have converted into decimals and we are getting the answer 28. We'll check whether with the last third question as well. Third answer we got was 111001 to the base 2. This was equivalent to 57. We will see whether we will get 57 or not when we convert this number into decimal system. See, this was the number, and you see it is having 1, 2, 3, 4, 5, 6 digit. If the number is having 6 digit, we need to start with 2 raised to 5. You may be understanding what I am saying, because you see whether when you had 5 digits we started with 2 raised to 4. When you are having 6 digit we have to start with 2 raised to 5. Always the power will be 1 less than the number of digit the number is having. Here suppose you see if it is having 6 digits, you need to write 2 raised from the 2 raised to 5. So 1 into 2 raised to 5 plus 1 into 2 raised to 4 plus 1 into 2 raised to 3. Remaining 2 digits are 0. See, 0 into 2 raised to 2, 0 into 2 raised to 1, and last digit is 1 again. So 1 into 2 raised to 0 means 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, 2 raised to 4, 2 raised to 5. We will see the answers. 2 raised to 5. What will be the answer of this one? 2 raised to 5 means 5 times 2 you have to multiply. We will make a rough calculation and see 2 into 2 into 2 into 2 into 2. That's the meaning of 2 raised to 5. 2 into 2 4 into 2 8 into 2 16 into 2 32. So here answer will be 32 into 1. So this will be 32. Next will be 16. Next will be 8. And these two answer will be the, see, 0 into 2 raised to 2 will be 0. 0 into 2 raised to 1 will be 0. And 1 into 2 raised to 0. 2 raised to 0 means 1. 1 into 1 will be 1. Now when we uh, find the sum of this one, 32 plus 16, this will be 38, 48, 56 plus 1 equal to 57. Again we have got the very same answer. That means we can convert any binary decimal number into binary number and binary number into decimal number to the same effect. Means there will be no change if you are following that, the exact steps of converting these numbers into decimal and decimal into binary, etc. So I hope now you have understood that now what I have said in this video. And now we need to study addition, subtraction, multiplication and division of binary numbers as well. It is not that difficult, but you need to understand some concepts to do that. And I want you all practice this, means conversion of decimals into binary and binary into decimals, and this concept should be clear to you before we go to addition, subtraction, multiplication, etc. So in the next video I will share you how we do the addition, subtraction, multiplication and division. And for now, you see you are given some questions at the back in your exercise part of the textbook. You can answer those questions and you see check whether you can find the answers correctly. Okay, try that questions and find out the answers. You can try more question. You write any question of your choice, means just simply write 75 and try converting that into binary. And after finding the binary, you can convert this back into decimal and see whether you have got say correct answer or not. If you have got correct answer, your conversion was correct. So you need to practice this one, then only you will be able to do it. Okay, thank you.